Yeah, hello. Good evening, everyone. Hello.
Yes, you're audible, sir. Good
Okay.
evening, sir.
Good evening. Mm, okay. So, how is so far? Week three. Good. Good. This week is very important, right? Are you comfortable with that?
It's a bit heavy. So,
Okay.
from what all of us understand that back propagation is very important.
Mm-hmm.
So, as expected, some of us have a lot of doubt. So,
Okay.
whichever way you want to do it. So, if you want to go through, because there is one additional document which is under the supplementary content.
Mm-hmm.
Uh, so that shows one or two problems how it's solved, right?
Mm-hmm.
And that is one. Second, if I don't know if you have a plan, sir, as if you want to go through the summary and then let
So,
us ask doubts or things like that. Whichever way,
okay.
I personally have a few questions which I want to ask,
Okay.
which whatever you think is right.
Okay. Okay. So, I was thinking if let's say somebody had a problem with any with any part of a slide, I'll explain that. Then I was planning to do a full pass. So we'll do one forward pass and then one backward pass of
So
any
best
example. Of any
best is
example.
that, sir. Best is actually
So
that.
I
That
was
will
planning to
give,
do that.
yeah.
But then I was expecting that that derivatives of like whatever back propagation, then I'll not go there and do that. Okay, for this derivation will be this, right? So well, that much is expected if we do that. So if you
Yes,
have
sir.
any doubt anywhere you are stuck, I'll explain now, and then at that point I'll just say that if you, let's say, you take last layer like loss function and you derive with respect to, let's say, predictions y hat, what will be the derivation of that.
Okay. So
So
yeah, yeah.
so
So I'm not sure about everybody, but I can speak for myself. I have gone through the all of it, and I'm guessing a lot of them have also would have gone through. They
mhm.
may have some questions. I have one or two questions. If you want, I can start. Others can then ask, and then you can go through the
Sure,
forward
sure.
and back
Yeah,
passes.
not an
So
issue, we can do that.
I'll just share the screen.
Okay.
So I was also trying to look at what Prof had. He had given some credits, right? He said he got inspired by these couple of lecturers. So
Yes,
I was
yes.
looking at their stuff also, try to understand. It's not obviously the notations and all are somewhat different.
Mhm.
But one question I have is, see, the biggest challenge I'm facing is, like, for example, if you take uh, sorry, let me just. Sorry. Mm, Okay, till here it's clear. So we start with this. So the left is what we want to achieve finally, correct? Because this is what we want to
Correct.
update, right?
Correct.
And not just 111, but 121, WL11, everything will get updated according to uh,
Yes.
their their impact on the loss function, right? Now, when we do this and when we start with the See, one struggle I'm having is that because there is no like live example in terms of actual data and doing them, so far at least, uh,
Yeah.
I'm
So
not
for
able
that,
to visualize how it will look like. Like, for
okay.
example, how does this vector look
Mhm.
like actually, right? Now,
Mhm.
one question I have is, so here we are starting by, if you take this, we're saying L
Mhm.
theta by the output, and then the output by A3, right? This is
Yes.
the activation, right? But when we actually go into it, we directly do L theta by A3, right? So this first step is practically, unless Sir had taken this to explain,
Mhm.
okay, this is how one hot vector looks like. Yeah,
Okay.
because see, because here we are starting directly with loss. This is L theta,
Mm-hmm.
right?
Yes.
And I don't need L theta by y hat to actually do this, right? I am directly
Um,
doing this.
Correct. So in this example, it is true. When we'll do so, this is example with respect to classification, right? So
Correct.
so when you'll do with respect to the linear regression, then this output actually there will be no softmax layer in that, right? There is really nothing at that point, like
It could be a simple like a linear function, or it could be an identity function. It could be
yes,
some,
yes,
but I'm saying L theta, directly as a function of AL, right?
yes.
So I don't need this. So I got really confused. Then it took me almost a day to, like, I didn't understand why we are doing this, because we are not using this technically anywhere.
Yes, we'll not use it, but to reach there, he has to explain, right? How did we reach there? I mean, how is it connected? First of all, with respect to loss, that AL part, how is it connected with the loss? It is connected through that output layer only, right? Otherwise, it's not connected. So output layer is
Uh,
the mid portion between A3. It's a mediator between the loss and A3, right? So he needs to go there. Then only he can explain
okay.
A3
So
part.
yeah. So this is how it is. So okay. So but in while we are actually working out, we are directly doing L theta by A3. But okay, that's why he's explained it. Okay, got it.
Yes.
Because I was very confused because we were not using this anywhere. So I thought maybe I was misunderstanding. This is one question I had, and the uh, other one I had was. Mm, Guys, go ahead. Somebody, if somebody has any question, please ask. I'll just look for it. I may take a few minutes. Mm, and then this weight vector, this the structure in which, like, when you write the weight vector, when you write W1, right?
Yes.
You write W11, W12, right? And
Mhm.
then here we are pulling out the columns. He said,
Right.
columns and rows. That is
I'll,
a little
yeah, I'll
confusing.
explain that. I'll definitely explain. So
That
when we'll
towards
do
the
full
end he wrote this W transpose. So I'm very confused with the matrix structure. That is the
correct.
second question I have.
Yeah, I'll
Right?
explain that metric structure as well. So there is a little bit difference, but yeah, I mean,
These two questions I had, and
okay.
third was, if I was struggling to visualize, like, how does the the final weight matrix look like? How does it happen? So if you are doing an example, it will be very nice. So that's
Sure,
all
sure.
from my side.
We can do that. Okay.
Yeah, I am stopping presenting.
Okay. Okay. Anybody else has any difficulty in anywhere, like uh, I don't know, any derivative part or even forward pass, or else I can start with, we'll do full pass. So we'll do forward propagation, then we'll do back prop as well. Mm, okay, then okay, I can start. I think. Yes, I'll join. So I already joined, but I'll use another for sharing. Okay. Let's talk with this. Not an issue with that. Should I talk? Uh, uh, I've shared my screen. I think it's visible, right? So we'll do full pass. But, so yeah, first point is what is, how weights are being decided. And so first of all, how sir use any kind of you know dimensions and all. So we'll mostly use a column vector, right? Anything, let's say a1 is there something, so it will look like a column a11, then it's like a12, a13, something like this, right? But with respect to weights, um, there is little bit change, and the reason is so let's say when we compute a, right, what we do w transpose x plus b, right? So let's say my w transpose is something like this. So let's say for each neuron, my neuron is there, right? This is my neuron. That's a These are my inputs, right? These are my three inputs, and I'll connect with respect like this. So I have another, and then I'll connect that also, but like this, right? So first neuron. So we introduce weights like which layer it is first. So let's say layer one, then which neuron it is. So this is first neuron, right? So I'll call that one, and then weight one, right? Then again, like layer one, neuron one, weight two, layer one, neuron one, weight three, right? So if I want to write, let's say this with respect to him, like the second neuron, then I'll write layer one, neuron two, and weight one, right? And same like this, another one which is layer one, neuron two, weight two, and this last guy will be 1, 2, 3, right? So this is how I'll write uh, weights. But that's not the issue. How it is being represented here is uh, it should be column, ideally, like let's say 1, 1, 1, 1, 1, 2, 1, 1, 3, right? So which is respect to this neuron, right? This neuron I'm talking about. Okay, but we are not doing that. What we are doing is we are taking transpose of that, right? So um, I mean, so this is my usual W, right? But in this lecture series, you will see that W's are not being written like this, but they are instead written like this: 1, 1, 1, 1, 1, 2, and 1, 1, 3, like a row. The reason is we have to take transpose of weight, right? At some point, we have to take, when we'll do the multiplication, we'll take transpose of them. And for now, you can consider when we will initialize weights, we'll always initialize them randomly, right? So let's say this weight vector, the dimension it should have is, let's say, 3 cross 2, right? If I write all of them, so 1 to 1, 1, 2, 2, 1, 2, 3, right? So this was supposed to be the size, and W transpose would be 2 cross 3, right? And this guy we are calling W in this case. So that is a confusion which student might have. But in this course, we'll always call W transpose as W. Like, and the reason is we are going to initialize them randomly, right? So why first do this, then take a transpose of it, right? When you write a code or something, you can directly initialize it this way, and you will have it. Okay. Uh, so this is the confusion with weights. I think you understood, right? Vas.
Yeah. So one question. So just go up, sir. So this is so basically the first one is the layer. Second one is the output neuron, and the third one is the source neuron, or wherever it is coming from, which is basically
Yes.
one layer lower from
Yes.
wherever it is coming from.
Yes.
Now these are so from this matrix, what can I conclude? I can conclude that rows and columns, but going forward, when you say W, you mean actually W transpose.
Correct.
Is that how we understand? Okay.
Correct. So yes, going forward we'll use W, but that is actually W transpose. And like for now, we'll always call this only W, right? So when later on we'll have W transpose at some point. That means transpose of this only, right? This guy, not of this. Okay. So always remember that this is the only way we'll always initialize the weight, and then whatever equation, wherever something will do multiplication, something will always have this only as a W. Okay, this one. Okay, this one is always a W. So I'll write like W how we'll write is, so here we'll write layer, and yeah, something. So we'll have W. This is the first terminology is for layer, second is for neuron, and third is for weight, something like which weight it is, right? So uh, we'll just write here. So it's like layer 1, neuron 1, weight 1. Then layer 1, neuron 1, weight 2. Layer 1, neuron 1, weight 3. Right? So and so on. Any dimension you can choose. And same way we'll go here as a layer. Let's say I have how much m. So okay, I'll draw once. Like let's say I have, you know, p neurons in this, or let's say m neurons in it. Okay, and let's say this is my something, and I have p neuron in this. Okay, understand? Like p neuron, m neuron. Then the dimension of this is going to be, so I'll have p columns and m rows. Okay, so this will be one, how much, m rows, so m and 1, right? W1, m2, and so on. The last will be 1 mp. Okay, so p are connected to this, right? So and that's what
Excuse me,
this
sir.
column is. Yes.
So I can explain once again why it's M cross P and not P cross M.
uh why? Okay, so okay, see, we need to connect each of them, right? So let's say this is my first neuron. Okay, I'll have all of them, like p neurons connected into it, right? So we'll need p weights for first neuron, correct? So p weights will require for first neuron, right? And same as for all of them, right? And we have m neurons, and each row I'm representing, so rows will represent weights of each neuron. Okay, each row will represent weights of each neuron. Okay, uh, understood?
Right. The rows represent the weight
Yes,
of
sir.
what
Yeah.
each
Okay.
neuron.
Okay.
And
Yeah,
the columns?
yeah, and columns represent what, how many neurons are there in this, like
Right.
n neurons are there, right? So that's what column is. Okay. Okay. So this is how weights are being, right? So let's say if I write a1, right? So I'll write, okay, let's say if I have, you know, um, let's say something like this structure. Okay, 2 here and 3 there. Okay, so I have, oops, this, and this is also connected with all 3 of them. Okay, so how will I write my weight? How will I write it? How many rows will be there?
So this one rows.
Two
So for
rows.
one, 3 rows.
3 rows and 2 columns, right? So first will be connected to previously 2's, right? That's why it will have 2 columns. So let's say W, I'll write 1 1 1 and W 1 1 2. Okay, and then second will be W 1 2 1, W 1 2 2, same 1 3 1 1 3 2. Okay, so this is how I'll always represent weights. Fine. Now let's say I have A, which I'll represent as WX, not transpose, plus B, right? So B will be of how much size? How much size I'll require for B?
B, you'll have three.
3, right? Here,
Yeah.
here, if in this case I'll require 3 Bs. So 3 cross 1 B will be there. So uh, it will be B, let's say 1 1, B1 2, B1 3, something like that. Because this was first B. When we'll have more Bs at each layer, I'll have to represent this as layer, right? So first indice of this. Okay, and W will be that. So let's say W1 1 1 W112 1 W122 132, and I'll multiply it with x, right? Here this would be addition, so I have 2x, right? So let's say x1 and x2 for now, or generally we'll use h nodes, right? Like h will use, right? So let's say 1 0, not 1 0, but h11 h12, something like this, or
0 1 0.
yeah, sorry, I missed it. 0 1 0 2. Okay. Will always the previous h for that. So this is my a1. Okay, fine.
So here I'm not taking transpose, right?
No, because the reason is we initialize the weight in such a way that we don't need to take the transpose. So you can say transpose itself is a weight, right?
Okay.
So in our case, we are initializing weight in such a way. So see, first what we can do is we can initialize weight with see, the way we initialize this 3 cross 2, right? 3 cross 2 weights. But I can do initialize this way and then take the transpose and all settled. But what I am doing is I'm not initializing 2 cross 3, but I'm initializing itself in 3 cross 2 ways. So I don't need to take the transpose of it. Okay.
Clear,
It's
sir.
just an initialization part. I mean, nothing to do with any other thing, but how we initialize, and then we don't need to take the transpose. Just one step we are skipping. Okay, fine. So this was my A. Then whenever I'll have A, so this I'll call as pre-activation. Okay, A is called as pre-activation. Then what I'll do is I'll apply some activation function. So usually sigmoid and 10h is being taught to you. Later on, you will come across others as well, but for now, this two being explained somewhere, right? So sigmoid is 1 by 1 plus e power, let's say, sorry, so f of, let's say, z, if I call whatever z you input, you'll get this. And if I recall for 10h, that is going to be e power minus z plus e power z or something like this.
No, e power minus z plus e power z.
E power
And then
minus
the bottom is, no, on the top it will be, no sir, it's e power z, e power z minus e power minus z.
Okay. And at bottom it is plus.
Yeah, it's plus. Just the opposite, the other way around.
Yeah. Okay.
First
So,
is e power z. Yeah.
Yeah. So doesn't matter plus case, but yeah, it's sub minus z. So something like this. And
So can you go to the previous slide, sir? The slide above. This will also be a vector. It will be A12 and A12.
Yes. You will get
A1.
you will get a column vector, right?
Yeah.
You will get a column vector of size, let's say in this case 3 cross 1, but whatever your layer m cross 1, right? And if I took m as the current layer or next layer. Okay. Just so I now itself I tell you that if you take derivation of this, you'll get what f of usually we represent as the sigma. You can call it sigma as well if you like. Sigma z and then 1 minus sigma z. Right? It's just easy. So whatever you get this, like, say, this is sigma z. So something, whatever you get here, you will just write it as it is, and another one you will multiply with it, right? So usually you will get a column vector as sigma z, and what you will do is you'll have another column vector which will have 1 minus sigma z, and you will multiply both of them. Okay, element by. You can call like this, or no, probably multiplication here, and then something. You'll do this whenever you'll get this, and you will take derivative with multiplication of sigma z and 1 minus sigma z. In this case, it is 1 minus whatever this f of z is. I'll take square of that, right? So So first, I'll have f of z already, right? Because I computed while doing the forward pass, right? So that's when from there I'll use it. I'll square it and I'll subtract it from the 1, right? So this is also another. I think I'll get column vector. Okay, so both of them will be column vector. We'll see. We'll take one example with numbers and all. I
Okay,
think.
this is not
And
clear, sir.
then
The square, how did you get the square?
so this is derivation of it. I mean, you need to
Okay, okay.
go and check it. So this is derivation of f of z with respect to the z. Okay. This is also derivation of let's say sigma dash. I'll call it sigma dash. Both of them are derivation. I'm telling you now because it's easy to remember that this is what it is. And if you are interested, you can maybe do the derivation itself, okay, for yourself. But this will be helpful while doing the back propagation. So we reached, let's say, here.
Sir,
to,
I have one question, sir. On the top, if you go back,
sure.
let's say the output is it's multi-level classification. It's not just +1 -1. Let's say there are 3 classes, right? So you have the y vector, y predicted will have 3 values, and then or will have basically the output. We kind of put it through a softmax, and then you get 3 values for the y vector, which will compare versus the true class, right? So we have these 3 probabilities, which will add up to whatever 1, because softmax will make sure it adds up to 1.
Correct.
Now, I have seen a couple of examples outside, not in our course, where you have 2 outputs, right? Like -1 +1, but somehow if you have 2 output levels and you take and then you put it through a sigmoid individually, they will not add up to 1, right? So that I
Why?
found very
No. Why it will not add up to 1, right?
no, each one is a separate sigmoid function. Huh? It's not a softmax kind of a
Okay.
thing.
If you apply but then you'll need one sigmoid only, right? You'll need one sigmoid.
No, I've seen a couple of examples. Yeah, no. So if you have, let's say you have 2 outputs, just output layer, you have 2 outputs, right? I can say this as whatever y1, y2. Right now,
Okay.
each one, the input I'm passing it to a sigmoid, they need not add up to 1. If I don't, right? So there are cases where that is also being done, and then they run the loss through. So it doesn't necessarily add up to 1. So I'm not sure if there's a standard thing that if you have more than one class, I mean, there will be more than one class at least. It always adds to add up to 1. Is there a rule like that? Because if you use softmax, it will always add up to 1. Right? But is there a rule like that? Because I need not use softmax. I can run each of the whatever predictions, y1, y2, y3 through a sigmoid, and I'll get some value between 0 and 1. But they don't necessarily collectively add up to 1.
Correct.
Right? So is there a rule that you should always use a softmax? Or?
Yes. So I think, are you talking about, is it are they doing same thing at the output layer, or they are doing an input, any hidden layer?
Output. I'm talking about output layer.
Okay, I have never seen this, but as part of thing, we always seen that we'll use softmax as the output layer, and that's what I have also seen others resources also.
Okay, thanks.
Yeah. So yes, so let's say this was my input. Maybe you can call h0. I got my a1, then I got my h1 also from sigmoid or any tan h or whatever you used. Okay, it's a activation. Then let's say we go further and define. So this is my first hidden layer, right? Yeah, first hidden layer. I don't want to call it h1, but something like hidden one. And then let's say I have another hidden layer. I'll again do same thing, right? I'll compute a2, which is w. So whatever w2 is mine, I'll take a2 is equal to w2 multiply it with h1, and I'll add bias to it. So let me call it b2, and I'll have that, right? So I'll have a2. After that, I'll compute h2. So same, I will use sigmoid or 10h or something like that, and then I'll have h2. So nothing difference between hidden layer 1 and hidden layer 2. But now I'll have a different layer, which is output layer. So let's say I have 3 classes, and they all are connected with all of them, right? All of them. Now I have A3, which is which doesn't change much from A2. So I'll have W3 H2 plus B3, right? Nothing changes here. But now I'll use softmax if it's a classification problem, and if it's not, I can just let it be. I can just don't use anything, and at after this I'll use loss function as squared error, right? Mean squared error. But let's say it's the softmax problem. So softmax is, so let's say I have 3 inputs. I can call, like, let's say P, Q, and R, which I got from some layers, right? So P, Q, R, S. You can have any number of um, output, but in our case it's 3, so I took 3. But you can have more also, P, Q, R, S, right? Any number. Then first element will be e power P divided by e power P Q plus R plus S, right? This is my first one, and you'll have, let's say, e power Q, and then the same summation. This part I'm calling as summation. Then same as R, and then summation, and then e power S and the summation, right? So that's how you'll get your softmax output. So softmax, and you'll give last layer to it, and you'll have this vector, this vector, which I wrote here, but you can call as e power P and summation. The next element will be e power Q and the summation, e power R and the summation, and e power S and summation. Okay, so this will be softmax, and I can call it as y hat also, because this is what we'll call prediction, right? This were my prediction. Now I'll compare it with my true y, right? So for that I'll require the loss function. So in our case we'll use cross entropy. So let's say L theta, which is I'll take summation of all of them, right? So y I, and in this course we'll usually take ln, natural log. So you can take ln, and then y1 hat. So whatever I predict, right? So this is what I predicted. I'll take that, and what is my output, true output, right? I'll compare them, and I'll add from 1 to k. K is the number of classes we have. So y will be represent like this. Like, let's say my first class is true, right? Out of 3, so I'll represent it as 1 0 0. If my second class is true, then I'll represent as 0 1 0. If my third class is true, then I'll represent it like this. Okay, so this is what one hot vector is of y. So usually, in while doing, let's say, programming or something, you'll not get like this. You will get some class, right? Let's say this row belongs to class 1. This row belongs to class 2, something like this. But you have to change this vector to this form. Okay, so this class 1 will be changed to, let's say, like this, 1 0 0, right? Later on, when you will do programming, if you don't, that's okay. But for now, understand that this is how we'll represent y in this case. That any class will be there uh, where true class is present. I'll put 1, and rest all become zeros. Correct. So since rest of them will be zeros in our cross entropy, wherever my loss is present, that will only exist. Rest all become zeros. Right? So you will end up having what, ln y, some 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 uh, some class, right? So let me call it L, and that's what you will have at the end as a loss function. Okay. And one more thing I want to add to this is, in our course, when we are doing this full pass, we have used stochastic gradient method. Okay, so stochastic gradient, in stochastic gradient method, what we do is we pass one sample at a time. So I'm not passing any other sample after this. So if I pass another sample, like next sample, then I have to sum. Okay. So what I mean by that SGT part is, so I got my loss as, let's say, L theta as minus ln y um, ln y L head, right? Something. So this is what I got. This for one sample, correct? And if I don't use SGT ways, and if I use the normal way, right, which is like batch gradient descent or stock, it's okay if you don't understand now, but what is batch, but I think you know, right? You have done MLP, MLT, it's all being there. If we use full batch, let's say, or anything, then I'll do add all of them, all these losses, okay? Ln, let's say, YL something, 1 plus, you know, so summation, so this negative will be outside of this, okay? Ln y2, and then so on, right? How many samples are there? Let's say n samples are there. So I'll have this whole thing. Then I'll do back propagation in that cases. But for now, the example is, or in the course, we will use SGT thing to understand it, and it's easy to understand, right? So the main task is we understand this, then we'll maybe uh, do this part, the full batch gradient descent. If you like to do it, you can do it, but it's very complicated. Okay, so uh, just to make sure that, let it be. Okay, so I'll not use full batch. I'll only use SGT in this. So now my one sample is passed, and I can do back propagation. Correct? Is it okay for all of you? We'll start back prop.
Yes.
Okay. Okay. So full pass is complete, right? So we computed A1, H1, A2, H2, A3. Then we computed uh, phi hat, and then we computed loss also. So this series of things you have to compute, and let's say we'll use sigmoid for this problem, and now I'll do the back pass, right? So let's say we wanted to compute. Okay, so one thing I want to tell you is, in this, wherever weights are there, right? So here, let's say W1 is there, W2, or let me call B1 as well, B2. Here I'll have W3 and B3. Right? So this um, 6 types of weights will be there in this 3 layered, or 2 hidden layered, and 1 output layered, something like that, neural network, right? Uh, so this was our, let's say, neural network, and this 3 kinds of weights you will get, right? And your task is in pair propagation. You'll update the 6 kind of weights. Right? That's what your task is. So let's say this is my output, and this is my input, and this is my H1 and H2. Okay? Yes. So first task is, how will I do with the last one? This is my W3. Okay? How will I do this? So first I need to check where it is connected with W3, right? So first it is connected with Y hat, then Y hat is connected with maybe AL or A3 in our case. Then A3 is actually connected with the weight, W3, correct? This part, if you see, that is going to be somehow what is like one, I don't know, y hat, something like this, right? And where it, so one will be there wherever it is true label, right? So it's I is equal to L or something. But to be frankly, I don't use this. You can write it like y hat minus y, and it's the same thing. Okay, you can write it like this. you can maybe ignore this part. Is it okay? Moving forward, I'll use this one. I think that's okay.
Yes, sir. It's okay.
Yeah.
Okay. So let's say y hat minus y, and if I do okay, so this is actually going to be a column vector like this, a column, right? And my weight is a matrix. So something I'll get as a row from this, which is my h2, right? So whatever h2 is there, I'll take a transpose of that, right? And that's why I'll get this weight, derivative of weights. Okay. I think it's understandable. Now let's do with respect to, let's
I
say,
have one question in the above things.
okay,
In that one hot thing, you'll get the rest as all zeros, and you'll get only one value, right?
correct,
Which is where I is equal to the true label.
correct.
But in this
No,
y hat minus y,
Mhm.
no, sir. So in one, sorry, wait. See, y hat will have values across the column, right? Y will have one in only one place and zero everywhere.
No, I am
So that
representing y like this, right? See, I already told you that I'll write like this y, right?
okay,
Like
okay.
this.
You're
So
writing it as a one hot.
yeah.
yeah.
So this is my one hot y, or that's what I did, right? I wrote one, then something. So this was representing it. I think it should not be one. So it's like e or something. Okay?
EL they write, sir,
Yeah,
as,
something. But I
basically.
use this only mostly. So
Hmm.
this is much easier. Right? I know what is y hat. I know what is y. This should
Clear,
be
clear.
column, and this is a row, right? This is h2 should be in a row, and then when you will multiply them, you'll get a matrix, the whole matrix, right? So that's what you will get with three loss function derivation with respect to third weights. Okay. Now let's do it with the second. Oh, you can do it with bias, right? Which is, let's say, let me do it with w3. In that case, I don't have this h2. I'll just have one. Okay. So what is it is going to be? It is just going to be y hat minus y. Like this, and which makes sense also, right? Because my, let's say, b3 was also a vector, and I'm getting this as a vector, column vector.
So can you just go up, sir, 1 second? Will you share these notes later? I was
Yeah,
just
I'll give you that. Not an issue.
okay. Okay, sir.
Right. Okay. This is better or this is better?
This is better.
Okay. So this were b's, and this was my, you can say, y hat minus y, and these were all the b's in it, and that's what you will get for derivation of b3, right? You will get one here, so nothing to worry about. Okay. Now let's do it with respect to w2. See, I know in lectures we didn't do like this. We did little bit different, but you understood that part, right? So I'm not doing that way, because ultimately you will require this all this mathematics for computing this gradients only, right? So let's do it with w2, which is, let's say, how it is connected to it. So first it is connected with um, my predictions. Then my predictions were connected with my whatever a3 was there. Then my a3, right? A3 is connected with h2.
Right.
Right? A3 is connected with h2, and then my h2 is connected with a2, and then my a2 is connected with w2. Okay. So this part I know. I'll get y hat minus y, column vector, this part we'll see what we can do with this 3. So A3 by H2 will be weights only. I think we did that also. A3. No, we didn't do it. We directly reached here. So we didn't do it. So A3 by H2. So this is the first time actually, we are, I think you see if we have done MLT or some MLP or somewhere, we never do any kind of derivation with respect to the inputs, right? We always do with respect to weights. So this is first time we are doing with the inputs which are going in the neurons. And what we'll get is it's W only, right? We'll get W of this. But there is a difference is we will multiply it like this, like W transpose, and then we'll do the multiplication. Correct? W3 in this case. This is how we'll multiply them. Then what is this? This is let's say sigmoid. So I'll have sigmoid of A2.
One question, sir. Why am I taking the transpose here now?
A good question. So the thing is, when you'll take this derivation, you'll have the W in such a way that now you want to multiply them, right? So you'll take a transpose, then only it's possible. And even though like let's say see this is a column vector, right? If you have a weight vector here, how will you multiply? It's like not possible, right? Because this is one element, and then
Right.
there is nothing here. But you need to multiply in such a way. So it's just a way of writing, so that you'll require it in the left also, in the left of this part, and then you have to take transpose also. Then only the multiplication is possible.
Okay.
So basically, I need to go into the derivation part then, and then tell you why we are doing it. But to make it easier, that we want to multiply them. That is the task. How will you do it? So that's why I need to write it in the left of my this part, and then take a transpose over so that it can multiply.
Okay.
So just to clarify again, this W3, let's forget the transpose part. W3, the way we are writing this in the course, at W3,
Yes.
W3, the weights are written as row, not as column. W3
Correct.
transpose will make the row weights which are written as row into a column.
Correct.
Okay, I just wanted to reconfirm that. Okay, got
Yes.
it.
Yes. Correct. So yes, correct. So whichever
but
way
is
we
there a
initialize, right? Whichever.
Yeah,
Good.
see, you had said that ideally weight should have been written as a column, right?
Correct.
Ideally, right? But is there a rule that it has to be written in a column? I mean, there's no rule, right? I mean, you can
No,
write
there
it
is.
whichever way.
So why I'm saying that, because in this course we are using all of the all of the initialization, or all of the weights, or all the vectors or columns or something we are writing them as a column vector, not a row vector. Okay. So that's why it should be. Otherwise, no, there is no such rules, I think.
No, in fact, you're doing the other way around now, sir. If you just go back to the first slide, sorry, this is very a bit confusing. If you go back, yeah. So here you had written, W11, W12, W13 as a row, right? These are the weights,
These
correct?
are supposed to be weights. That's what I'm saying, that we are not following this route.
No, we are
We'll
not
go.
following. We are following the bottom one. We
Yes.
are writing it as a row. That's what I'm saying.
Yes.
You're writing the weight as a row and calling that as a W instead of calling that as a W transpose.
Correct.
Okay, that's. I just wanted to confirm. So whenever you'll say W, I'll think of it as a row. Weights are
Correct.
rows.
Yes, definitely. So rows,
Because
which is related to first neuron. The first row.
correct.
Second row is
Correct.
related to second neuron.
Second neuron. That is the target. Wherever we are going, the target layer. I
Correct.
think somewhere in the lecture, I got confused because somewhere in the lecture, I think somewhere midway, sir says that we'll take the column vector, which is the weight vector. Then I got really confused as to why he was saying that. That's why I'm like clarifying it repeatedly. Anyway, go ahead, sir. Go ahead.
So, here. So okay. This this is what I have to do to get this right, which is I'll take weights and take transpose of it and move it in the left of it. So that I have the multiplication very good. Right. That's why I'm doing it. Now the next part is I have to do something called element wise multiplication. So I'll use this symbol for element wise. So element wise means what it's a11 is, let's say some u is there and some v is there, right? So let's say u1, u2, v1, v2. So element wise means u1, v1 and u2, v2. That's what element wise multiplication means. And this is a sigmoid derivation, right? So which you already did. So let's say sigma a2 1 minus sigma a2. This is also going to be a column vector.
So
Whatever.
the
So this is
W3
all of
transpose W3 transpose is dA3 by dH2, is it? Is that why that?
correct.
Okay.
TA3 by, so this guy is here.
Okay.
Let's see. This is element wise multiplication. So I can't disrupt the order of it, right? First I have to do multiplication of this two, then I'll do element wise multiplication. Okay. So now I have this again, which will give me what h it's h what h1, which is going into a2 transpose of that. Correct. I'll take h1 transpose and then I'll have the whole thing. So this is all the multiplication you have to do to get uh, the derivation of loss with respect to weight 2. Okay. Fine.
So last one is do A2 by.
This is a row. This is a row. The column. This is also a column. Multiplication of what we'll get. Column 1. Yes. Both, if you multiply matrix with this matrix multiplication, you'll have column 1.
But this H1 also has to be solved. It's not yet solved.
Has to be what? Solved.
Yeah.
H1 is already derived, right? When you're doing the forward pass.
Yeah. H1 is sig whatever A1. You did it right. Sigmoid. Basically, sigmoid of A1 is H1.
Right.
So you already found it. So you don't need to found it again. Like, you
Okay.
just need to break these pieces together and then you'll have this derivative. Like the way it is, how should you multiply it?
So if we get a question on backward propagation, sorry, and this will be given the H1, or we'll have to do the forward pass and then take out the back propagation.
So most likely you have to found all those things, right? Whatever
Okay.
is on the screen. Yeah, let's do it. So last one weight is pending. We can do that also.
Sir, what would be DL with respect to DB2?
Yeah.
B2?
Okay. Same thing. It's just one here, right? So let me write it with respect to B2. Oh, it's a small B2, which is going to be W3 transpose. Then I'll have y hat minus y. Then I'll take element wise multiplication, which is sigma a2 and 1 minus sigma a2. Okay. And I'll not have anything. 1 on. Okay. Just multiplication. So this is what I'll get with respect to B2.
Okay.
Let's do it with respect to W1. Now again I'll write all the things. So see how you remember that you can do it in different ways. So how Sir explained this is little bit different, but ultimately this is what you want to do. Okay, this is what you'll come across uh, in question solving on in reality, right? That uh, vectors and all. There actually it's all never being put together. What you will get with respect to W1? How will you, because there he will write like something as the A1 with respect to the A1 by the W1. Then you go and find this, which is like a recursion kind of thing. You write this as DL by A1 as DL by A1 is 2 by H1 and then the H1 by A1, right? Then you'll go again in recursion, like what is this? What is this? So something like this, right? So either you go this way, recursion, do recursion kind of thing, kind of recursion, and then you kind of end up having same this guy, which I wrote here. Okay. Uh, actually it's the same thing. The way you want to write, you can write it, okay? Whichever you feel easy. But let's do this way. So first I'll with y hat with last layer with what's h2 with respect to a2, then a2 will go to h1. So now I am at h1, then I have to find h1 with respect to a1. Then a1 is the guy who will give me w1, right? So all of this multiplication I have to do. This part I know. This also I know kind of. Right, whatever we did this until this part I think we did it. Then here we did something different, right? Like you can see till here, right? So this all thing you can maybe bring here. It's your choice. Then you have to compute this 3 points on. So let's say this threes are you can maybe write it as what TL by this all point you can write TL by A2, right? Yes, and then you'll have the A2 by tau or tau h1 by tau a1 by tau w1. Okay, so this all we already did it, right? This is what same thing. This part you have to take same nothing changes there. And you got what you got a column vector, some column vector you'll get this guy. Now what will be this a2 by h1? A2 by h1 will
The
be again,
DL by A2 will be that long thing we did last time, right? I mean,
yes,
that
yes,
will be a
last
matrix. This will be a matrix, right?
no, this is going to be a column vector only, because see here this
Gotcha.
column is there, this is column vector, this is column vector. I'll do element wise multiplication, and this only column, because last part will make it a matrix. This multiplication with h1 transpose will make it a matrix.
But we have a W3, right? We have a matrix to start with on the left.
Yes, but I am multiplying matrix with a column, so that will give me a column only.
A column. Then this is a column into column.
Yes,
And
this
then
element wise.
column.
This is element wise. Just for.
Yeah, so it will be a column only.
Yeah, column only.
Right.
And then
But
I'll
last
multiply
one
with
will
the
be
row.
that will be a outer product, na?
Outer product. That's what. Row is that, and you'll do outer product.
So it will give me a matrix. That's what I'm saying.
Yeah. This is yes, correct. This will give you matrix, but I'm not using this last term. I'm not using it. This last part.
Yeah, we are not using. Yeah, there we are not. Correct.
I'm using
Okay.
this one.
Yeah, correct.
Okay,
Correct.
this is a
Correct.
column
Correct.
only.
Correct.
So this is a column. I'm not using that. Now A2 with respect to H1, what I'll get? Weights. Correct? I'll get weights. In this case, which are they? W2. Right? So I'll take transpose of that, which I'll multiply with this again column, and then I'll have this guy is a sigmoid. This part is a sigmoid, so which will be sigma a1 1 minus sigma a1, make it little smaller, 1 minus sigma a. Fine. This is also a column, but I'll do element wise multiplication. Element wise. So this is a column, both of them. This is a matrix, but multiplication with it is will make it column, and this is also a column. I'll get a row from it, which is H1 transpose or
Zero. It'll be
H0. Yes, that's right. H0 transpose. Okay, this is what I'll get from this. And if you do all of this multiplication, you will again have the matrix, the whole matrix of this tau L by tau 1. Okay,
So that
you'll have
WT transpose is representing what, sir?
W2, this guy.
Yeah.
These are weights of second hidden and
Yeah. So see,
between
from the
between first and
second
second
hidden.
hidden. Sorry, first
See,
and
from
second hidden.
second.
Yes.
Yeah. So from second hidden, we are getting a column matrix.
Second hidden, I'm getting a column.
If you can just go up, sir, once.
Yeah, sure.
Earlier one.
This way.
You had shown this, right? So
Yes.
this one, this is. So we are taking till the last one. We are not taking that dou A2 by W2, but till then we have a column matrix.
Yes.
This is
Column
what we are taking. The whole
Yes.
thing is what we are taking for the next one also. Correct? Because this is what we will use in the
Correct.
dou L by dou W1, right?
Correct.
So if you just go down now, sir. So that is that first part, DL by D dou A2.
Yes.
Correct?
This part which I didn't write. So this empty part is that.
Yeah, that's a column matrix. What
Yes.
is that W2T, sir?
This I got from this guy. So now
Okay, again the same thing. Okay.
Again, I'll do this. So this is here. Okay. Here. This is here. And this. So all of them. So this part is, whenever you take derivative of what activation with previous previous input, right? Something H1. Then you'll have this W2, which is which should be bring in front, so that you'll have a good multiplication. Otherwise, you'll not have multiplication. Okay, you can maybe see this. You can remember it this way also. Let's say I have a column or a matrix, and okay, something like this. I have a column and I'm multiplying with the matrix. So this is one element, right? How will I multiply with all this? It's not possible. This matrix is not, this multiplication is not possible. So I need to bring this guy here. Now, the this all things are equal to this numbers, right? All of them. So that's why I can do a matrix multiplication. Otherwise, it's not possible. So that's why I need to bring this W2 guys prior in front. Now,
Got it.
now I have the whole thing. The last part is tau L by last part is tau L by B1, right?
Correct.
Which is same thing. Set to transpose the whole thing which I computed earlier, and then I'll take element-wise multiplication. I'll have sigma a1 1 minus sigma a1, and I'll multiply it with 1, nothing, right? So this will give me a matrix, the whole matrix you get. Sorry, this will give you a vector, and which will be multiplied with 1, so nothing. But here in this case, since you are multiplying with a row, this is a row, so you'll get a matrix. Okay.
So the last one, this is the last one you are multiplying. That is a column vector again.
Which last time multiplying?
This
This
dou L
h0.
by dou B1 towards the end.
Yeah.
That one into one. That is a column
In,
vector.
into one. One is you can take it column vector, or you can, yes, but it is column.
Actually, yeah.
Doesn't matter.
Yeah. Yeah, actually, because
It's one. So, but it should be row. Okay, it should be row.
so then you'll get a matrix, na?
Then I'll get a matrix. Yeah. Then. Correct. Then I'm not sure. Like, yeah, but it should be one. Okay. So
I think it should be an identity.
yeah, it should be identity. I think so. Yes, it should be identity, right? It should be identity. Then only I'll
Okay.
have this, and nothing, and nothing. Yes,
Why
yeah,
should it
it
be
should
an
be.
identity, sir?
So identity will not change it, right?
No, I agree.
Mhm.
But but this is basically you're taking the derivative, right?
Yes, derivative. So
And you multiply it by 1. Now, how is it multiplied by an identity matrix? I didn't get it.
So see, when you do it at an element level, you get a one, right?
Mhm.
Now to convert, but when you put it each element, B has multiple elements, right? B1, B1, 2, whatever, right? So when you want to replicate that structure for a matrix, the equivalent of one multiplicative identity is a identity matrix. So that's why you create identity matrix for just to
and
make the
it's,
multiplication work.
yeah. Or you can ignore it. That's fine. Okay, just not doing anything will work. Correct. I mean, see, this all we have to somehow do it. Like, let's say mathematically we want to write this as a code, or we want to make it work. So either you can ignore it while writing. Let's say you want to do multiplication with one, and you don't do it because that will not change anything.
Right.
So can you just go back to that first one, sir, where dou L by dou B3? The first one I missed.
So P3.
Yeah, in this, you had explained that this one will be what, sir? I didn't get it. Right, you were very
This
fast, actually.
is, oh, okay. So see, we did this part, right?
Yeah,
Do I need to do A3 by W3? No, right?
no,
So what I have, y hat minus y, and that's what it is, and I am doing
yeah, and
multiplication with
because
one.
yeah, then you do dou A3 by W3, and A3 is plus B1, so you'll get a one there, right? So correct.
Yes, fine. So this what a full pass is. I updated all the weights. I did this thing. Now, maybe we can take the example which is, I think, given to you as a back propagation. We can solve that. And yeah, maybe I'll download it. So I'll choose this. I'll explain using this only. Now, yeah. So here, see, it's mentioned how we'll initialize the weights, and this is the only way we'll be initialized it, right? This is the way we'll always use in this course.
And when we take the transpose, we'll take the transpose of this only. Way.
Correct. We'll take transpose of this one. Oh, so my question in this, the question is, so these are my weights, right? These are all my weights, and this was my x 100, or maybe we can, what we can do is we can, let's have this. Like, oh, hold it. We can do it, right? So the structure is, so from weights only I can figure out the structure, right? So but let's do it.
Sir, if
So
you can just draw the first two layers and draw the
yeah,
weights, so that again
I'll
we
I'll
are
I'll draw all the
yeah. Okay, sure.
things
Thank
here,
you.
right? So this is my input layer because I have x101, correct? Then I'll have 3 cross 3, right? So I don't need to think much because I have 3 inputs and um, 3 neurons, right? So one is connected with each one of them. So this, the weights are from here. It is right on image. So this guy I'm talking about, and so this is my first neuron, right? So the weights are 1, 0, and 0. Okay. With respect to second guy, if I write, let's say this second guy,
One, one,
then
one.
then my weights will be 1,
One,
1,
one, one.
1.
Okay.
Okay.
Very clear. Very clear.
And I'll not write next because it will get more messy. Then let's say I have another hidden layer. So this is also a hidden layer. This is H1, maybe I can H2. Again, I'll need 3 only. Then as output given to me as 0, 0, 1, right? So from this I know that I'll require um, say 3 only, right? Something. So this is my y1, y2, and y3. It's a one hot encoder of not gaps, but so whichever will come. So here it's saying the third classes are true. That's why I represent as 0, 0, 1. If it was first, then I would have represented 1, 0, 0. Second, 0, 1, 0. Okay. So this is my neural network and all of it. So now let's write the A1. Okay. Yes, A. So A1 will be whatever my W is, which is 1 is 1, 0, 0, 1, 1, 1, then 0, 1, 1. So this is my WS. I'll multiply with x, which is 1, 0, 1. I'll add bias. I think bias is not there in the question, so I'll ignore it. But you have to add the bias, right? Maybe that's 0, 0, 0. But in this case, we are ignoring. We're not even updating it. But you have to do it if, if it's given to you. So this multiplication will come out as 1,
Two.
1 of this, 2 of this, and one of this. Okay, so this is my A1. You can call A11, A12, A13. Okay, this what it is. Now I'll do H1, which is a sigmoid of A1. In this case, what I'll do is 1 by 1 plus e power minus 1, 1 by 1 plus e power minus 2, and last one is also 1 by 1 plus 1 by 1 e power minus 1. So this all vector I'll have. And can anybody, what is the first term or something?
Yeah,
You
one.
can compute that. Or maybe you can look into this PDF and help me. So,
The first one is 0.731
mhm.
power
Right.
minus 1, 731.
So H1
Then
is 0.73.
31. Yeah,
Yeah,
3.
let's take up to 2 because I have to write more.
Yeah. Next is
0.88
88 and
and
0.73.
0.73. Right? Nothing changes here. So this is my H1. Now I need to find what A2, which is what are my weights is. I think 111, 111, 001. This was my weights for A. This is my W2, and I'll use H1, which is this guy, okay, plus 0.73, and I'm ignoring the bias. Okay. I'm just writing it so you know that bias is there, but I'm ignoring it just for this question. And this will be the addition of all these three will be 2.34,
2.34.
2.34, and 0.73. Fine. Now I'll apply sigmoid again, H2.
0.912.
So now you know, right? I'll not write 1 by 1, 1 by 1,
Okay.
power minus 2.34. You understood, right? This is what you have to follow all the elements, and you'll have output as
0.912
0.91, 0.91,
and
0.67.
1 second.
Fine. Okay. Now I had
Yeah.
H2, so I'll compute A3, which is W3 multiplication with H2 plus what B3, right? And W3 is 100, 100, 111. Right? This is 0.91, 0.91, 0.67 plus nothing. Just leave it. So this will be 0.91, 0.91, and 2.49. And then now I'm at the output layer, right? So I'll take a sip I had or output activation function, and I'll take with respect to A3, which is going to be my softmax, right? So softmax, how will I write? E power 0.91 divided by e power 0.91 plus e power 0.91 plus e power 2.49. So the summation will remain constant, like for all three, in our case, 3 units, right? So maybe you can, e power 0.91, and then whatever the sum is, same thing. E power 2.49 and then sum, right? So this is all we'll do, and you'll end up having 0.15, 0.15, 0.15, 0.70. 0.70. So this is my y hat. Okay, so I have predicted it. Now let's find ln or loss function L theta, okay, which is cross entropy, but we know that ln y hat, which one? Which y should I consider out of the
The
three?
last one, no? That is the
Right.
true label.
Because my y is 0, 0, 1. That's why I'll consider y3, right? And that is going to be ln 0.70. If you compute this part, you'll have 0.35. So I've done full pass. Sorry, forward propagation. Right? Forward pass I did it. So now I have
So this
weights.
part, that last one I didn't understand. So just 1 second, sir. No.
Okay, see, I'll do it. See, cross entropy is from I is equal to 1 to 3, right? You'll have
Correct.
y1, true y1,
Yeah,
then
yeah,
ln.
yeah, everything will become 0, 0. Correct, correct, correct,
Right?
correct. It's
So this
0
is 0.
multiplied. Yeah, correct, correct.
This is
Got
0.
it, got it.
And then this guy will remain, which is 1. So that's why
Yeah,
I'm also not writing this y3.
correct,
1.
correct, correct.
And then I'll have this guy.
Correct. Got it. Clear, clear.
Okay.
For a second, I forgot. Thank you.
So the summation should be, so I'm writing, so I. Okay. Yeah. So now I have loss. I
You have to
found it.
put negative sign also.
Yeah, negative. I forgot that negative, right? So this is my loss. Now the question is, first let's do it with the easier one, which is in last layer. So let's say W311, or if we go to our diagram, this is, they are asking 1 1, right? So in last layer, but 1 1, which is this way. This way they are asking. Okay, this is 1 1 in last layer. If they ask 1 2, then 3 1 2, then it would be this 3 1 3 is this. If it's 3 2 1, so this is 3 3 2 1. Okay, so to be clear, this is what they are asking. Okay, let's find that. It's very easy, since we know that this is what I have to do. So I can do it with this, but let's do it with the whole matrix, and that is y hat. Then I'll have y hat with respect to a3. Then I'll have a3 with respect to w3. Then so this will give me a matrix. From that I'll pick up the first guy, right? So this matrix will be there. I have to pick up this first guy. Yeah, correct. So this is going to be a just y hat minus y column, and this is going to be h2 transpose.
Why do you want to take a column? Because y hat only has one component which you already know because it's cross entropy. So it's much easier to just put h3 there, del L by del h3.
Yes, you can do that, but just so you know that this is the first element I'm picking up. You can do that, definitely.
Okay.
Sorry, say that again, Anupam. Sorry, I missed that. Sorry. Say that again.
So if you look at the diagram that Manoj has drawn at the top,
Correct.
I'll go there.
there the only impact of the loss is from y3 because y1 and y2 are 0 because of the cross entropy formula, which you just talked to him about.
Correct.
Okay, so since y3 is the only one which is impacting, so when you do del L by del y hat, basically you are doing del L by del h3 because h3 is the only one which is getting converted to the loss function.
Correct. Okay. Okay.
Did you
Okay.
understand that? That's the most
Yeah, yeah, yeah.
important part. If you understood that, then it's much easier to understand because then the calculation become easier by this method that is being shown. Otherwise, of course, the formulas they require all the vectors and matrices. But this one, so it will basically become del L by del H3 into del H3 by del A3 and then del A3 by W311. So it's a fairly straightforward computation after that.
Yeah, whichever way.
Yeah.
So that's what. There are multiple ways you can remember it. Technique. So I follow this. I write all of them and then figure it out. It's far easy.
Yeah, this is, I also find this to be very, very straightforward and very little chances of error if the
Yeah.
calculations are done properly this way. No formulas, it's just a straightforward chain calculation.
Correct. And that's what I found easy. So that's why I'm doing. Your way is also correct. You can maybe go with another way, which is I think present in this PDF. It's your choice. So y hat we computed, which is this guy 0.15, 0.15, and 0.70, and y was 0.01. I'll do subtraction between them, right? I'll do subtraction between them. Whatever I get, I'll multiply with h2, right? So what is my h2? My h2 is this 0.91, 0.91, 0.67, and transpose of that. So which is 0.676. That's what. And you'll get metrics out of it, right? The whole metrics. But the thing, the element they are trying to tell us is the W11, right? So 1 you'll get with multiplication of first row and first row here as well. 1 2 will be one of this and second call, right? Second call. You can do it anyway, whichever way you can recall, or you can write all of the things, right? But I'll do is what I'll do is I'll write the whole thing and then we'll choose it. Okay? So here we have 0.15, 0.15. I'm subtracting it, and in this case I'll have negative 0.30. Okay? And 0.67. Now let's do the multiplication. What is this multiplication? 0.1. This multiplication is again 0.1. This multiplication, you can tell me, correct?
If you give me 2 seconds,
Correct.
you can do it in a calculator if that's okay.
Yeah.
Or
Yeah, fine.
uh,
I'm also doing.
0.10 will come.
I'm also doing. Yes, sorry.
Okay. Okay, I'll calculate that.
Yeah. So with respect to 0.67, it is 0.10. This is also 1.0. This multiplication would be negative
0.15.
and last guy will be 0.67, so just 0.2. So this whole matrix is there, and they are asking about anything. Let's say this is one, in our case 311, W312.
So can you just go above? This negative is last one will also be negative, right?
Last one will also be a negative. Last one also negative. So this all 3 1 3 2 1 2 1 3 2 2 3 2 3 3 3 1 3 2 3 3 3. So this whole weights were there, and derivation of that is this guy. So on anything is asked, let's say 322, it's this one. 333, it's this one. But the question asks about 311, which is 0.12. Fine. This is what my answer is.
now, when we have to update the weights, it's simply the original weight matrix into whatever learning parameter
Yeah.
of this
So
into
my
this.
one let's say W3 is there. I'll take some learning rate minus this guys, whatever I got, right?
That's it. Okay, got it.
That's all. So this all are derivative and all. I didn't wrote that, but del or something, right? Del, yeah, because I like del, maybe too many dels, but a del of W3, or let's say W3 with respect to loss. Okay, this is what my updation will be. But then I'll do, of course, with respect to beta, sorry, bias also, but I don't have bias, so I'm not doing it. So this two updation will happen. Not two, but many inside this, but it's two kinds.
So just assume bias of 111 and let's just do it just to understand it completely.
Okay, fine. So see, my initial W3 was 311 was what, when I what was given to me? It was given 1, right? It was given 1, correct?
Right. Right.
And I found my this as 0.13. Okay, del of this W311, let's say 311 with respect to L theta, I found it 0.13. Now I want to update it. So let's say at timestamp 2 or 1, whatever, we started with 0, whichever way you count it, right? So let me write 2 because 1 we did it. So what I'll do is, this is my updated way, will be what was my initial one, which is 311 at t equal to 1 timestamp. I'll subtract this eta. So this eta will be the right. So learning rate, you can choose. Usually we choose very small number or 0.1 or something like that. 0.13. Okay. So 1 minus 0.013, which is, I don't know, very small number. 7, then 8, 0.0. Oh, sorry, not this. 0.87. No, 987. This should be. Okay. This is what my weights are after updation. 311. New, you can call it new or something. And the same way I'll do it for all of them. Okay. That's fine.
Yes, sir.
Now a little bit difficult. We can do it, which is given in the question. So from first layer or first weights, I can do anything. It's a 111. You can do that, and so tau L by tau 111. But what we'll do is we'll write with respect to 1 and then pick up the first element, right, of that. So whichever is given, you have to pick that thing. That's all. And this is like tau. I'll write all of them. Tau L by tau y hat, tau y hat by tau, what is A3, tau A3 by tau H2, tau H2 by tau A2, tau A2 by tau H1, tau H1 by tau A1, then tau A1 by tau W1. So now I'll have this guy. That's it. This little bit complicated, but this is again y hat minus y column. This will be a W3 transpose, which I have to multiply it. Then I'll have to take element wise multiplication with sigma. So sigma A2 and 1 minus sigma A2. So what I can do is, first I should compute this only. Then again I'll do, because what will happen is I'll have something like this W2 transpose, and then element wise multi, and this something like this I'll have again. That is completely. Then I'll do with weights, okay, which is H 0 transpose. but first I should compute this only to make it easier. Then I'll do the rest of the derivatives. Okay. So till now I am at this guy. Okay. Here I'm doing computation of this 4 derivation, which is all these 3 things. So let's write W3 transpose, which is 1 1 1 0 0 1 and 0 0 1. Right? This is my W3 transpose. And y hat minus y was, okay, again forgot. Check. Now, let me write this on, correct. So 0 0.15, 0 minus 0 0.30, 0 0.15, 0 0.15 minus 0 0.30. Fine. Now I have to do this sigma A2, which is, or you can write it as a H2, 1 minus H2. Same thing, nothing different. So let's find who is H2. Here, this is H2, 0 0.91, 0 0.9, 0 0.67. 0.67. Then I'll do multiplication it with 1 minus 0.91, which is 0.09. 0.09. 0.0. Oh, no, not here.
0.33.
Here it is 3, right? 0.3. And that's what I'll get. So this is element wise. Okay? This I can't do. So I can't change the multiplication. Like I can't do first this and then go here. Something. I have to do this first, then only I can do this multiplication, because this is going to be element wise. Okay? Let's do this. So this is 0. This is
0.15.
minus 0.3 and minus
Yeah.
0.3. Okay. Now I'll do element wise. So first I need to figure out what is this. 0.91 into 0.09 into 0.09, which is
0.082.
8,
81.
0.82,
82.
whatever. You can take 82. 0.82, and the last one is
0.22.
0.22. Then I'll now again multiply element wise. So first is 0. Second is
82 into 0.3. It's 0.024.
okay, minus 0.024.
24.
Okay.
Next one is
Minus
will be
0. So it's 0.066.
66.
So this is my till this guy. Okay, till this 4 things are there. So I got this column vector. Now what I have to do? What is
Now,
H2 by H1?
now you do again W2.
Yeah, W2 transpose. Then I'll do again element wise multiplication with H1 and 1 minus H1. Right?
Correct.
So this I'll again compute, and W2 transpose is 1 1 0 1 1 0 1 1 1. Fine. This is 0 minus 0.024 minus 0.066. It's to element wise of H1. Let's see what is H1. H1 is 0.7388 and 73. 0.73, 0.88, 0.73. Then I have to again multiply it with 1 minus 0.73, which is 727, 0.27.
28 or whatever.
This is 0. 0.73, 0.8873. So this is 0.7.
Yeah, 27.
Two,
Uh,
sir.
I mean, oops,
Yeah, 1, 2.
this is 1, 2. This is again 0.27. I have to multiply them, right? Each of them, and this is also column. So let's do this first. This guy I have to do, and that will be only minus 0.024. This is also minus 0.024. This is summation of all three, but this two I can take, which is 0, 1, 8, and 9, 0, 0, something. Okay, I'll do element wise multiplication with this.
That is point, first one is point 197.
197.
0.10, you can take 106.
0.106.
Yeah.
Okay, so this now I have to do element wise multiplication, and here actually you can stop. I mean, you don't need to do all of them now. I mean, or if you know this, what you can do is let's say you want to figure out which is 311, right? Then you know that the first guy will come into picture. Rest I don't need to compute. So it's just you can figure it out when to skip. But for me, I I do it all of them. It doesn't make much difference. So yeah, so let's do it for our case. We'll do all of them. Then we'll have the last guy. So one guy is pending out of this A1 by W1, which is going to be H0 transpose. Right? But for part of this multiplication, let's do it. What is it? 0, 4, 2, 9, 7. 0.0047. The next will be
0.025. Yeah.
then negative 0. So 177. It's something like this. Now I need to do it with H naught. H naught is 101. H naught transpose. And whichever element you want to figure out, you can do it. Let's say you want first one. It's going to be 0.0. I mean, same. Nothing changes there. Next guy will be 0. Next guy will be same thing. 7. Okay. Asked in PDF it's asked 1, 2, 3. So this is W1, 1, 1, W1, 1, 2, and 3. Now in next layer it is going to be. So first one is 0.0025. 0, same thing. 0.25. Okay, I don't need to do much space. 0 minus 0.077. The question, the web propagation PDF, the question is asked about 1, 2, 3, which is this no, second neuron 1, 2, 3. This guy 0.0025 is the right answer. That's what it's given to 2, but I think it's 2.5. Okay, 0.0025. Right. So I did that.
So can you go to the PDF where this?
Okay, yeah. Okay. Here, okay.
Yeah, if you come down,
Mhm. More.
Yeah, more. No, above. So here, the last line, the last, yeah. Here, shouldn't it be negative 0.002?
Correct, right? It should be negative, so they missed it. Because you can see element wise, it should be negative, right?
Right. Okay.
Yeah, so they missed it, but we did it correct. Negative 0.
Can I make a small request if it is possible?
Yeah.
Just see, actually, this topic, the number of calculations make it quite confusing, I would say.
Mhm.
And this gets compounded when there are some misses in the solutions. Is
Okay.
there a way to audit the solution
This one
by
you want?
somebody?
You want to
No,
update this one?
so there are no. I mean, what I mean to say is like there was one in the GA1 solution. There was a mistake.
Correct.
What happens is that when we don't realize that there's a mistake because we are struggling with the calculations anyway. Is there a
Okay.
way to just review the solutions once? Not all of them, at least for the first week, first quiz one.
Okay.
So
So
I'm
this
solving these
is.
anyway. I'm solving these
Mhm.
anyway. Just for your information. I'm
Yeah,
sure the
sure.
others also doing that. So, or maybe
Um,
we can bring it up on discourse if we find a discrepancy.
yeah, that would be better because we can update it. Okay, so bring it to Discord. We'll definitely update it.
Okay. Okay.
It's better
Thank you.
if you bring it up. So we if I go and find it out, I might miss it again also. If I start solving all the
No,
questions,
understood. Understood.
right?
Okay. Okay.
Quiz one,
Thank you.
you mean PYQ, is it? Like last
Oh
exam?
no, not PYQs. Yeah, this
Credit
GA1,
assignment.
GA2, GA3, GA4, there's back
ये
propagation
वाला.
sheet,
Okay, okay.
all of these, right? So because we are all relying on the solution, sometimes we get confused that is our answer wrong or is the given answer wrong. That
Hmm. Okay, got it.
And uh, you can see same amount of calculation they are also doing, like whatever this PDF. You can follow this way or the way which is, but they are both same. There's nothing different I'm doing. It's just
Your way is better, sir.
okay. I'm writing all
yeah, I
of them
found
in
it
one
much
line.
cleaner. Yeah, much cleaner. Yes.
Okay. It's just you need to remember this guy, this W2 guy, which will always come in front whenever you do, because then only
Right.
multiplication is possible. And
Right.
and you can go to slides and check it out why it is, if you are not confirmed with why is it, right?
So this solution, you'll post it
What
on discourse or
I'll put it
this
in
notes?
additional, says supplementary content. I'll put it.
Right.
I'll put in Discord also, not a issue. Okay. Or I can do it now. It will take some time, but I'll put it on supplementary content, definitely.
Supplementary would be fine, sir. Right.
Yeah, definitely I'll put it there. Fine. So I did the full pass. I think that solves all the questions. Anything else? Okay, fine. Should we close it then?
Excuse me, sir.
Sudeep has raised his hand.
Oh yeah, okay. Yeah, go ahead.
Yeah, Pritam just mentioned something about GA solutions in the chat box. I also wanted to ask about that. Would you be releasing solution PDFs for the GS?
Uh,
I think two are already released.
2 are already released, so yes, 3 will also release. So I'm not sure about this
Okay.
GA solutions. Why is that? Um, so previously in some meeting here, it's been decided that to degree students, let's not give solutions. Okay, I'm not the one who decided; they decided. But now you are seeing GA solutions, so I don't know why it is being there. It's
Yeah,
not
so
my
the
part to.
reasoning
Yeah.
I talked to JK.
the
I don't think
reasoning from
anything like
my
this is. Yeah, Preetu, go on. Go on, Preetu.
yeah, so my reasoning would be whatever issues we face in the grade assignments, the first point of reference should be the solutions. If we if you're satisfied from the given solutions, then we did not come to the session and ask you for an explanation or
Yeah,
create threads on discourse. So
definitely,
from
definitely.
your part as well, it would become easier. That's all. I mean, I have no other reasoning for that.
Yeah, no issues. I see. I don't mind if they give you solution or if they don't give you solution, but uh, you know, if they ask us not to give, we have to also comply to that. And
Yes,
if
that
they
makes
let
sense.
us give
Also,
it to you, we'll give it. So for now, they are giving it to you, and I will let it give it to them. Give it to you. Okay. I don't mind. I'll not
sure, sure,
interrupt
sure.
or
Thanks.
something. Yeah.
Thank you so much.
Sir,
Yes.
hello.
Yes.
Actually, if we are done with week two, I had put something on the discourse and you had written one line as a response, a couple of
Uh-huh.
lines. I didn't understand that. If you're okay,
Oh
can I
yeah,
just,
sure, sure, sure. So I'll write
I
here,
can,
but I'll remove it. Okay, just
I'll go to the discourse.
yeah. Want to go? You will share your screen.
Yeah, just sharing.
So if you plot this, e power the sigmoid function 1/1 plus e power minus 2, where will it be? E power minus 2 at
Sorry, sir.
0.
Say that again. I didn't understand.
So
I didn't
so
hear
if you
that.
plot a sigmoid function, which is usually 1/1 plus, let's not 1/1 plus e
Correct.
power minus z, right? Minus z, correct? And if
Correct.
you plot it at 0, you'll get 1 by half, right? Half. So at 0, you'll
Yeah.
have half value, correct?
0.5. Correct. That's the.
So you, if you want to shift it to a little bit right, it's at 2. What will you do? Why 2? Because after 2 you want it and not below 2. So what will you do it? You'll make z is equal to 2.
Z is equal to.
2.
You're taking e power minus z, right?
Yes. And
One. Yeah. Correct.
right. So how will you get z equal to 2? If you have uh, w0, let's say w0 plus w1x is equal to 2. That's what you want, right?
Correct.
And in our case, I think x is 1 or something. That's why, or x, sorry, I have to choose x in such a way. I mean, something like that.
Because that was
So,
not my question, sir.
yeah,
I think
okay, good, good.
you're probably mixing it up.
Yeah, sure, sure.
I can't recall if I asked that question. Let me just check. Maybe I did
Yeah,
and I
go ahead,
forgot.
go ahead, go ahead. I'll
So this was the one. Oh, sorry, I'll just share my screen. In this one, what I wanted to understand was I think I got the answer, but I didn't understand what you said. So I just wanted to clarify eventually. See here, initially I got, you can see my screen, right?
yeah, I can see.
Initially I
I can
got
see.
confused because there is only one input here. So why do we have two weights? I got confused with that. Okay, but that is
Yeah.
probably just to keep the structure, similar. Like there is everywhere there's two weights. So you've kept that,
Yes.
right?
Yeah.
And for this, I worked out all the values. For everything, I was getting -1. So I was confused whether I did it correctly or not, right? Because whichever value you take as the input, you'll get -1 as the output, -1 plus, right?
Correct.
Then you had written this. I didn't understand
Okay.
what you
So
meant.
yeah, that was the only I was going to say. See, we have two towers, right, which are open from
Correct.
two sides.
Correct.
Something like that, right? So and both of them will form a tower. So if you
Correct.
will merge them, all of them, correct? So wherever the, let's say, the left tower will have one value and the right tower will have one value, will add up. You'll add them up, right? So you'll have two at that point where both of them are one, correct? And we want to keep only two wherever it's two and not below two, right? So for that we are using sigmoid function to make it happen, correct? So that sigmoid function should be some way in that way that at 2, it will go at 1, right?
It
Something like
should
that.
have a threshold of 1, then only the 2 will come. If the sigmoid function has a threshold of 1, then all the levels will go. Level 0 and level 0 will become 0 and only 2 will come.
He's saying threshold should be 2 because we are
No,
adding
no.
up two functions.
No.
Sorry,
In
sir,
the
go ahead.
adding up, you'll do in this slash, you're doing the adding up. Plus
Correct.
1 plus 1.
Correct.
Yes.
Correct.
That is forming the sum. So you'll get level 2, but you'll get everything else also. So
Yes.
the last sigmoid function is getting rid of the riffraff, the level
Everything,
zeros and
yeah,
the level
correct.
1s.
Correct.
Yes.
So that at threshold is the 1 will clear out all that, and you'll just get a cuboid of 2. Okay. But that height of the cuboid will be not 2. It will be less than 2 because your sigmoid function can be only between 0 and 1.
I still didn't completely get what sir, what you had said, honestly. But going back to the conversation you were having independently,
Mhm.
this.
Can you? Okay. Yeah. So go ahead. First, ask the question. What is?
No, the thing you were explaining, that 2 minus 2, like if you just take it as a simple sigmoid function and take a bias and move it around, how the whole thing moves. Can you explain that which you were trying to explain to me?
Okay. So see, let's say if I tell you at you want to classify things, let's say less than 0 as class 0, okay, something,
Correct.
and more than 0 as class 1, right?
Correct.
So you'll require step function. That is correct. Right. So how will you get step function using sigmoid? You will use high values of w.
Correct.
So that will solve it. Okay. Now you want it at 0, so you kept it as 0, right? So z, when z is equal to 0, then that step function is forming at 0, right? You want to shift that
Correct.
to 2, right? Because you want more than 2 now.
Yeah.
Correct. More than 2, keep it. Less than 2, scrap it off. Make it 0.
Correct.
Make it 0, right? So you want to shift
Correct.
it to 2. How will you do it? So you make z equal to 2 in your sigmoid function. So 1 by 1 plus e power minus z. That z should be 2. Is it okay?
Correct.
So that's why this values are there. 100 by 50. You can take 200 by 100. That is also not easy. You can take it. Anything like this will work. So this the reason for this 2 should come is because you want to scrap it at 2, right? And you want it to have a height also with like kind of step function, which make it like kind of step function, correct? So that's why you will use any of this value, it will work, but not small values. I didn't mention that, but you have to keep at some high values, and this ratio, and then it will work, correct?
So can you show the
Yeah.
diagram once again, sir?
So, but we actually have, so B by W should be 2.
So yeah, the diagram, in the diagram, the W weight, can you just go back to the diagrams?
Here?
Here, this weight minus 200 it should not be there because that's giving a wrong when I tested it. This should be plus 200 only, the last W42.
What are you saying, Vivek? W42 should be
200.
200. क्या हो सकता है? More possibly.
Be 200. That could be, right? I think even I'm not sure, okay, that much, but okay,
The
looking
minus
at
is changing the orientation and it's not giving the tower. So it has to be 200 only.
yeah, could be that. That could be. So I think so you will use another W to shift the orientation. Right? You want to
Yes.
make it perpendicular to the other one, and
Right.
I think
So-
so. You're right. I think both should be negative. I think, or
Or both should be positive, right?
yeah, yes, yes, it should be negative 200, both of them. Then only it can. So you can actually plot it in. It's given to you, right? This
Yes, it's given. That's how I
GeoGebra.
was plotting, and I was checking it out.
Yeah, yeah.
So
So,
either
so if
both
you
need to
do
be
that, and
negative or both have to be positive, right?
yeah, you'll figure it out what should
Yeah.
values be. Don't recall it how these plots will happen and all. Just you can just go there and plot it and see it. That will be much easier.
And the higher the difference between these B3, B4, the flatter the top will be. I mean, it'll become like a plateau. So if that difference between B3 and B4 reduces, it becomes more like a curve. And it
Yeah.
reduces in the length also. So this difference also has to be maximum. So which
yes.
is correct, which is minus 100 plus 100, that is correct.
Acha, because then they are farther apart because they are farther apart from each other. So the top becomes flatter.
Right.
Okay. Okay. So bias will shift it to so positive bias will shift it towards the left, negative bias will shift it towards the right. So anyway, they're opposites of each other. Correct. Okay.
Yes. Is it clear?
Almost almost clear.
Yeah, not an issue.
I do
Can
go back and look at it again.
yeah, you can actually plot this. What I would suggest is plot the last one given to you, sigmoid function. Okay, just sigmoid function, and check where it is forming, and try to change the values in such a way that it classifies whatever is at 2 more than 2 and then less than 2. How will you do it? So that for that you will require this. I mean, see, you are getting less than whatever you are calling value, whatever you did, because maybe you didn't check the part where it is going more than 2 also. Okay, because now it's not in the range of 0 to 1 or something. It's huge. The range is huge. So
Okay.
it will be a little difficult to solve it manually. You have to rely on plots now.
Lalit, this video you shared, is Lalit there? Oh, he's left, is it? Okay. I'm just wondering, this video which is shared, ye kya hai? I mean, it's like it. Lalit is a TA, is it?
No, not in this term. But he was
Okay.
TA in last term. So I mean, he is a good person. He's agreed to help any student if they have any difficulty.
Okay, okay. No,
So
because
if
he
you have
shared
any,
some video, so I was just wondering, and he said he kind of last term he was saying something, so I got confused whether he's a TA or okay, got it. So basically, he's volunteering to help. Okay.
okay,
Okay, that's all from my side, sir. And
okay, fine. Thank you then, everyone. If there
Thank
is
you, sir.
nothing, we can.
thanks a lot.
Session
Thanks
was
a lot.
very helpful.
Yeah, yeah,
Yeah.
very helpful.
I'll upload
Clarified.
this
So yeah,
slides into
the slide. Sir, will
supplement
you be sharing the video also?
live session.
Yeah.
It's there on YouTube. This link, I think one posted is of that only.
1 second. 1 second, sir. Okay.
You can have it. So here I messaged it. This is today's session.
Got it. Thanks.